We are going to look at domain and range of an exponential function. So we have slides 23, 24, 25, and then 26 that we need to complete. So let's look at example 1. So remember, domain is all the possible x values. So if we look at this, see how we have the arrows on the end, so it continues on and on. So domain is our x values. So since it continues on and on, there'll be a no break in the data. So x is all real numbers. X is an element of, that's what that little symbol means, all real numbers. We could also write it as negative infinity is less than x is less than positive infinity. We did domain back in the spring, in the fall, with linear functions and discrete data. So range is the y. So y'all remember we talked about asymptotes? It's a horizontal line, or it could be a vertical line that makes it where the function doesn't cross that line. So in this one, it's going to continue as you get closer and closer to 0, but never actually touch. So I'm going to do a little dotted line here for my asymptote. And my function gets closer and closer to it without actually crossing or touching it. And so this equation is written as y equals 0. It's our horizontal asymptote. So what that asymptote does is it restricts our range. It makes it where you can't cross or you can't have certain numbers as your y values. So in this case, y cannot be below 0. So we're going to write this as an inequality as y has to be greater than 0. So y can be any number that is bigger than 0. It's not or equal to because it doesn't actually touch it. Okay, let's go to example 2, right beside it. And this is a different looking exponential function. So it's going up. The x values can be anything. It's not restricted. So we can write negative infinity is less than x is less than infinity. All real numbers. And then the range is restricted by any asymptote. So again, there's an asymptote. And it's right here. It's at y equals 0. So the function will never cross it. It gets closer and closer and closer and closer without actually touching it. So in this case, it's all the y values that are below 0 instead of above. It's below. So we'd say y is less than 0. Go to example 3. An exponential function containing the following points are there. We need to do the domain and range. Best way to do it is graph it. So if you're doing your EOC and it gives you this but doesn't give you a graph, in the back of your EOC booklet, they always give you graph paper. You can tear that graph paper out and you can work on that. You can draw anything on there. Math related, EOC question related, don't just get on there and start doodling. But y'all know what I mean. We can use this graph to graph the functions. So we have 0, 1. So 0, 1, 1, 2, 2, 4, 3, 8. And I didn't do the negative 1 half. What do y'all see as the pattern here? We don't look at the x's. The x's are just in order. What is the pattern? What is the rate? Times 2. What is our starting amount? 1. So we can write our function as our starting amount times our rate raised to the x power. So that means the further right you go on your x values, it'll go up by multiplying by 2. So it's going to continue to get bigger and bigger and bigger. But if you're going to the left, the opposite of multiplying by 2 would be divide by 2. So it's going to keep on dividing by 2, but never get to 0. There's no way to take a number, divide by 2 to get 0, except for 0. 0 divided by 2. So what does that tell us our asymptote is, where our asymptote is going to be? It's going to be at that y equals 0. So domain is going to be all real numbers from negative infinity to infinity. And then our range is going to be all the numbers that are greater than 0. So y is greater than 0. Example 4, let's use our calculator. If you don't have one on your desk, go get one or use the one on your computer. Go ahead and put that equation into y equals and let's graph it. So I'm going to kind of sketch it right here. So where is our asymptote going to be? So y equals 0. It's going to get closer and closer without actually touching or crossing. And the way you can tell that, because it looks like it might be on top of it, you can look at your table and if you look at your numbers, as your x is increasing, what's happening to your y value? It's decreasing too. See, those numbers are getting smaller and smaller. Okay, what does that mean? Do y'all remember? Did we talk about this? It's your scientific notation. So that's 9.8 e to the negative 4, which means you're going to move your decimal to the left 4 spaces, which means it's going to be a really, really small number. You can keep on going. And does it ever go to a 0 number or a negative number? Okay. So that's another way of looking at it to tell where it's at. All right, so the domain is our x's. Our x's are all real numbers from negative infinity to infinity. And then what about our range? It's what? Yeah, greater than 0. Y is greater than 0. Number 5, an exponential growth function with a y-intercept at 2. Okay, so we only know it's a y-intercept at 2, so let's draw the 2. Draw the point at 2, the y-intercept. And then what does that mean, exponential growth function? How is it going to look? Huh? Yeah, it's going to go up. So it'll start down low and it'll go up. And we don't know how it actually looks, but it's something like that. We know it's at 2, but it's a growth function. So the domain is going to be all real numbers again. And then the range y equals 0. The range is going to be where y has to be greater than 0. Okay, the last one on this paper, an exponential decay function with the y-intercept at 4. So let's plot our point at 4. What does exponential decay mean? How's it going to go? It's going to go down. So start here and then just go down like that. Something like that. Nope. Did I do that right? Did I do that right? Yeah. Okay. I was worried for a second. Okay. So our asymptote is at 0. So our domain, again, is all real numbers, negative infinity to positive infinity. And our range is where y is greater than 0. We have one more slide in exponential functions. So let's look at that. So exponential growth or decay. Do y'all have this slide? These slides are, I think it was from Monday. Add these slides. So click on it. Then you're going to click each one, hold down the shift key, and then copy. And then go over here and hit paste and click match existing or keep existing. I think that's what it says.
We add them at the end.
Yeah, just add them at the end. Okay, y'all help each other around you if you're having trouble.
Is this linear versus exponential blank data supposed to be blank?
Oh, yes. We are not going to do that. What slide was that?
I think slide 24, but
Yeah, delete that one.
Can we delete the percent graphs too?
Can we go through our journals because mine has all kinds of jacked up.
Mine too.
Yes, we can look at it. Let's see real quick. Here, I'll show you mine.
Oh wait, pause. My computer's very slow. Okay, you're good now.
Okay, the first actual slide was slide 3, a problem string of exponential multiplication. Exponents are multiplicative. There we go.
3 is the, in case you were wondering, the toolbar.
Yeah, so is mine.
What? That's, oh, okay. I just had it wrong. Sorry. This is number 5. Sorry. I forgot what the numbers represent. Okay, and then 6 is trees and acorns. 7 is exponent review up top. 8 is bunnies versus viruses. And y'all are taking pictures and uploading them. And then 9, multiplying with like bases. And then 10, 11, and 12 is that tweaking parameters.
Can we delete those?
Y'all did it on paper.
Yes.
Do what?
Yes.
Yeah, y'all did it on paper. I don't think y'all turned it in. Y'all kept it,
We
right?
put it in our journal.
You should put it in your journal. All right, you can leave those blank. If you upload pictures, that's fine. If you didn't, that's fine. Okay, let's go to 13, dividing like bases, part 1, and rational exponents. 14, dividing like bases, part 2. 15, let's get messy. Y'all turn that one in. Okay, so you don't have to put that in. Then 16, raising terms with exponents to a power. That was problem string, take a picture. 17, laws of exponents. 18 was practice on solving exponents. Y'all might have taken a picture of that or wrote it or typed it in there. 19, we did together as class, so you should have a picture. Percent graphs, we did it in our journal. You can leave those blank or you can upload a picture. I won't count it off. Then 22, exponential functions, growth and decay. And then that starts 23, 24, the ones that I just told y'all to copy and paste. So anything else that you have beyond that, you can trash. I think there's a blank data one. So what I want you to do is you can go back and watch this video to make sure you have it all right. So we just did slide 23, 24, 25. Now we're going to do slide 26. Okay, and it starts with growth or decay. So you might have an extra one in there, that blank data one, which was slide 24 before?
That was not slide 24.
Okay. All right, so let's look at this. Line A, what kind of exponential function is this? It is an exponential decay. It's going down. Oh, it has 2 A's on here. Why does it have 2 A's? I don't know. The purple line, how about that? The purple one is exponential decay. I'm going to change the color of my text to white so I can actually see it. There we go. I'm going to bold it. All right, and then the green one, that is going uphill, right? So it's an exponential growth. There we go. So if it's a decay, that means that your rate is going to be a number that's between 0 and 1. It'd be like half or a quarter or 0.75, 0.95. It doesn't mean it's going to be negative. It's just a number that is less than 1 but bigger than 0. All right, so let's look at these 3 more. Domain range. So let's look at this one. Okay, what do you notice about this one? It goes past the 0, so that means that there's not asymptote there. But it also doesn't have arrows. Do what? Open and closed circle, exactly. So when we talk about our domain, we need to create a text box. Our domain is our x values. What are the x values that it could be? What is x is looking at our x axis. So how far left can it go? -2. And then how far right can it go? To +2. So on the x, The furthest left that there is a point is at -2. The furthest right, the point is at +2. But this one's not included. So when we do our domain, x is between -2 and +2. Do you remember doing this? So then we just need to put our inequality signs. So they're both less than, but one of them, if it's a closed circle, it's going to be less than or equal to. Okay. Less than or equal to. So insert that symbol. My keyboard will do a shortcut. If I do Control, the less than sign. So I don't know if y'all's will do that too. It might be a different. Yeah, you could just or you could insert the symbol. And then the other one is not or equal to, so it's just a less than symbol. What is wrong with this? Ah! There we go. Okay, the next thing is our range. Range is the y values, so we look at our y-axis. How low does the function go? Does the graph go? -5. How high does it go? +10. I'm going to make these different colors. So then the y value is between -5 and 10. So we need to look and see if it's going to be a less than or less than or equal to. On the -5, it's open. So it's just going to be less than. But on the 10, it's or equal to. I didn't do it a minute ago. I have no clue. I'm just going to copy it because I don't know what I did. Magic. Okay, do you have any questions on that one? Just remember domain is x-axis, so you're looking at your x-axis, which goes from left to right. So you see how far left it goes and how far right it goes. The y-axis is up and down, so how far down does it go and how far up does it go? An exponential function containing these points. So let's look and see, can we write the function of this? What is the start value? That's our y-intercept. What would it be at? Huh? 0, 1. So we put it at 1 times, what is the rate? If I go from one y value to the next, that doesn't look like it does anything. Times 5, and then times 2, that doesn't look right. So what we can do is we can use our calculator. Go to stat. I wonder if I did that one wrong. Did I make that problem up? I bet you I did. Go to slide, edit master. And fix this. This should be 25. I did it wrong. Go to slide, edit master, fix that 10 and make it a 25. Okay, now what's the rate? Now that we have it typed in right. times 5. So 1 times 5 raised to the x value. And if you're unsure on that, that's okay. You can always just graph it. So let's graph this in our calculator to see what it looks like. Go to y equals, plug it in, 1 times 5 raised to the x. Let's look at the graph. So then where is our asymptote at? 0, y equals 0. So how is that going to affect our I was on the wrong one. Our domain is all real numbers. From negative infinity to positive infinity. And then our range. It'll be y has to be greater than 0. Okay, the last one, an exponential growth function with an asymptote at y equals 0. So that is just like what we've been doing. If the asymptote's at y equals 0 and it's a growth function, it's going to start. It's going to be like these, right? Like that. So exponential function where you have your asymptote at y equals 0. So this is your asymptote. Y equals 0. So it's going to be a growth function. So it's anything that goes like that. Just as an example. So then our domain and our range, what are they going to be? What's our domain? What can the x values be? All real numbers, anything. What's our range? Yeah, y is greater than 0. I'm going to copy this, paste it down here, and then just delete the function. Okay. So your assignment for tomorrow, since we are not going to be in class, is to finish your digital interactive notebook, turn it in, and then do the domain and range assignment that I gave y'all on Monday, and then work on your EOC review. You don't have to finish it, but your EOC review is due on Monday. So Friday we'll come back and we'll start the quadratic unit.